right, so last thing we're going to look at this week, still section 5.3, it's just the second part. And what this part shows us is now that we know how to write a complex number in polar, okay, using the r cosine theta plus I sine theta, we can make multiplication and division much, much, much easier. Addition and subtraction, we can't really make that any easier. Okay, it already was easy the way we did it before. You just combine like terms. Combine the real, combine the imaginary. But division, even though it's not overly hard, it's a lot of steps. You have to find the conjugate, multiply the top and the bottom by the conjugate. And when you do that in the top, that involves FOIL. So you got to FOIL it. Then after, you got to combine like terms. You're going to have to change I squareds to -1, combine like terms again, and then you have to split it into two parts when you're done with the denominator. We can make all that go away using what we learned yesterday. Okay. So that's what I just said. There's other advantages to polar, but the main advantage that I'm teaching you is that it gives you a quick way for multiplication and division. In fact, based on the numbers, you'll probably be able to do them in your head. Okay? Without, I mean, if they're huge numbers, you can't. But even small numbers in rectangular, I don't think most people could easily FOIL in their head in under 3 seconds. Like if I said 6 plus I times 8 minus 3I, and then gave you that much time to do the answer. It's not that they're big numbers, it's just that there's a lot of steps. Well, this is going to be a lot better. All right, so we're going to suppose that we have two complex numbers. Okay, I'm going to call them Z1 and Z2. My first complex number and my second. Each complex number is going to be written in polar. Okay. And when we do an actual problem, you're going to have all numbers. If I could show you an example. Like this. R will be a number in each, and the angle will be a number. In order to show you the formula, I'm just going to keep it as general as possible. The first complex number, its radius is R1. The second complex number has a radius of R2. And the angle for the first complex number, for now, let's just call it θ1, the first theta. And let's call the angle in the second complex number θ2, the second theta. Okay, so if you wanted to multiply these together, the old way, I just went through everything you'd have to do. All the FOILing, the I squareds, the combined like terms, the conjugate, separate the fractions, all that stuff. All you have to do is, if you already have your numbers in polar, follow this formula. Okay. So the product of Z1 and Z2. First thing you want to do is take R1 and R2, multiply them together. Okay, start with that. So whatever R1 is, whatever R2 is, multiply them together, and that's going to be the radius in the final answer. The second thing you have to do is take θ1, θ2, and add them together. And that's it. So to get your answer when you multiply two complex numbers in polar, multiply R1 and R2, that's your radius, add θ1 and θ2. That will be your angle. So as long as R1 and R2 are reasonable numbers, you should be able to multiply them in your head, and the same with θ1 and θ2. All the same rules apply here. If you get a negative in your answer, you can fix it all the ways we've talked about. Let's try an example. Okay, so let's take these two complex numbers, and you can call them whatever you want. You can call them Z1 and Z2, you can call them A and B, X and Y, whatever you want to call them. First complex number I have is Z, the second one is W. Z is 3 cosine 20 plus I sine 20. And W is 5 cosine 100 plus I sine 100. Okay. And let's multiply them together. All right, so Peter, if I multiply those together, what's my radius going to be in the final answer?
15.
Yep, 15. 3 times 5 is 15. And Haley, what's my angle going to be in the final answer?
120.
Yep, how much? 120, yep. And you're done. That's the whole thing. Okay, so hopefully by doing that problem, you can see it is a lot faster to multiply complex numbers in polar than it is the old way. Okay, now, what's a little bit more interesting and a little more time consuming than that is showing why that works. Okay, all I did was give you a formula and say, here, follow it. Why does that actually work? That involves a proof with trig identities. We haven't learned trig identities yet. That's something we're going to do next week. So as far as why the formula works, we're not going to go through the proof. That's something in a full year class I would have more time to do. Not in a half year class. So any questions on that? Let's try one more. All right, so the second one, Z is 1/2 cosine 15 plus I sine 15. And W is 10 cosine negative 30 plus I sine negative 30. Okay, and I want to find Z times W. Right, so Eric, when I multiply Z and W, what would my radius be on the final answer?
5.
Yep. 1/2 times 10 gives me 5. Cosine, and Molly, if I add my angles, what do I get?
Negative 15.
Yep, negative 15. Okay, now let's say in this problem they told you to write your angle as a positive. You have 2 ways to do it. Can someone just give me one way to fix that so the angles are positive? I don't care which, I'm not going to do both, just one of the ways. Yep.
360.
Okay, and what would you get if you did that?
345.
345. Yep. Remember the other way, just take the negative away from cosine, take the negative from sine, move it in front. Again, even though there was a negative in the angle, still extremely fast to multiply. One little extra step at the end adding 360, but that's not too bad. Any questions on multiplying? Okay. Let's look at dividing. So if you want to write that again, you can, but I'm assuming the same thing that I just did when I multiplied. I have 2 complex numbers. We're going to call them Z1 and Z2 again. They each have a radius, and they each have an angle. It's exactly the same thing for the same starting point for multiplication. Okay. Now, anyone have a guess what we're going to do with R1 and R2 this time to get the radius in the final answer? Alex? Yep, you're going to divide R1 and R2. And anyone have a guess what we're going to do with theta 1 and theta 2? Peter?
Subtract.
We're going to subtract. Yep. And again, more interesting than just looking at a formula and plugging into it is why that works. And the reason why it works, you could also show using a little bit of algebra and trig identities. It's not overly hard to show why that works. We just, at this point, we don't know what you need to know to show why it works. Okay, so when you're dividing, Divide your radii, subtract your angles. Now it is important you subtract them in that order. Theta 1 minus theta 2. You have to do it in that order. Let's try an example of that. So for our numbers this time, we've got 3 cosine 75, I sine 75, divided by 5 cosine 30 plus I sine 30. Okay, let's start with our radius. Connor, what would my radius be when I divide those?
3 over 5.
Yeah, we don't have to change it to a decimal. Just leave it as 3 over 5. So 3/5 cosine. And Robin, what would my angle be when I divide those two numbers? Specifically, z divided by w.
Sorry, what?
What would my angle be?
That would be 75 minus 30, right?
Hmm?
That might have mental math.
Yeah, not sure? Sure. Yeah, ask them. 45. Yeah. So if we subtract those, and then you get 45 plus I sine 45. Okay. And that's how you divide them. So what we just did right there took the place of all the stuff you would have had to do with division. The conjugates, all that stuff I've said a bunch of times. The only disadvantage to this method is it assumes that your coordinates are in polar. So if your coordinates are not in polar, now it's a question, well, you'd have to change each one to polar. So that's going to involve a little bit of time. And then you could do this. So is it quicker to change them to polar and use this method? Or is it quicker to just leave them in rectangular and do the conjugate and I squared and all that stuff? That depends. Okay. But if it's already in polar, no question, this is faster. All right, let's try this one, and then one thing left, and then that'll be it. Okay, so z is 10 cosine 20 plus I sine 20. W, 1/2 cosine 100 plus I sine 100. Okay, when I divide those, what is my radius going to be? Yep, Peter? 20. That's, if you were thinking 5, you were thinking 10 divided by 2. But my radius isn't 2. It's 10 divided by 1/2, which is 20. Okay. And what about my angle? What about Irene? What's my angle going to be here?
-80.
Yes, it's going to be -80. And can somebody give me a way to fix that without adding 360? Let's do it the other way. Yep.
Drop the negative
Yep, just drop the negative from where?
from 80. So then it's just cosine 80.
Okay, yep, get rid of it from the part with cosine. Okay.
But we know that the next one's going to be the same, so it's going to be minus I sine 80.
Right, on the sine, you can't just get rid of it, but you can move it in front. So we subtracted and we fixed the negative at the same time. Any questions on? Okay, so we looked at multiplying, we looked at dividing, and I'm going to show you one more trick in polar that can really speed things up. What does that mean to do? Like if you had to do 2 plus 3i squared, and you had to explain that to someone who doesn't understand what it means to have a number higher. Well, they don't understand exponents. How would you explain that? Yep.
Multiply it by itself.
Multiply it by itself. So take what you have and multiply it by itself. So if we were going to do that out, we'd get 4 plus 6i plus another 6i. 3i times 3i is 9i squared, which is a negative 9. And then you'd combine like terms. What's 4 minus 9? Negative 5 plus 12i. Now, for that problem, I don't think there's a faster way to do it. Changing 2 plus 3i to polar and doing it that way, probably going to take you longer than it did for me to just do it the old way. But what does that mean? If you wrote 2 plus 3i to the 5th. Yep. To do what? Something 5 times, but not divide. Rudy? Multiply. So what that would mean to do is write this out 5 times. Clearly I'm not going to do this out. And what you'd have to do is FOIL the first 2, just like we did. And then once you get that answer, which is negative 5 plus 12i, you would FOIL that to the second one, get that answer, and then to the next one and the next one. You'd have to keep foiling it out. Now, even to the 5th power, you could still do that. It'd be a little bit time consuming, but you could do it. Now, if we had something like this, to the 536th power, now it's getting kind of ridiculous. You can't do that this way. It's going to take way too long to write out 2 plus 3i 536 times and then FOIL each pair together. There might even be some little shortcuts in there, but still, it's going to take forever to do that. So in polar, you can do this problem just as fast as you can do that problem, or the one above it. They all take the same amount of time. And I'm going to show you the trick for that. Okay, so if you have to raise a complex number to a power, that's called, the shortcut I'm going to show you is called Demoivre's theorem. So Demoivre's theorem, like everything else we've done in this section, assumes you are in polar. If I asked you to do a problem like this, it would definitely be faster to change that to polar and do what I'm about to show you. No question. And the bigger that exponent gets, the more time you save. Okay, so for small exponents, like squaring something, this trick probably isn't worth it. Big exponents, definitely worth it. Okay, so the trick, if you have a complex number in polar, is take your radius, raise it to the power. Okay, whatever your radius is, raise it to the power. Next, you have to find your angle. To do that, take your angle and multiply it by the power. Okay, so when we do a problem, they'll give you something like this. They'll tell you what power to raise it to. They'll tell you the radius you're starting with. They'll tell you the angle you're starting with. All you have to do is raise the radius that they gave you to the power and take the angle they gave you and multiply it by the power. Okay, so let's see if we can figure out z to the 8th. This problem is already set to go with Demoivre's theorem because it's in polar. If it wasn't, you would have to change it. And that's what we did in the homework last night. All right, so can anybody tell me what am I going to do with the 3 to find my radius in the final answer? Right?
Raise it to the 8th.
Raise it to the 8th power. Now, if that number gets really, really crazy huge, we won't do it out. But 3 to the 8th, it's not that big. It's not like it's in the trillions. So we'll do that out in a second. So 3 to the 8th times the cosine of, what's going to be the calculation for my angle? Yep.
138 an hour, right?
Careful, does it say to do this with your angle? Does it say to take the angle and raise it to the 8th power?
Oh, no. Just multiply it, right?
Just multiply it, right. So the calculation is going to be 20 times the exponent, which in this case is 8. So what's, Emily, what's 20 times 8? 160. Now, when you multiply an angle by a number, sometimes it can get pretty big. Like if this was to the 20th power, it would have been 20 times 20. It would have been huge. What can you always do to an angle to make it smaller if it's bigger than 360? So we've had negatives and we've fixed it so to make it positive, but what if you have an angle that's too positive? What if it's too big? Yeah?
Subtract 360.
You can always, yeah, you could subtract 360. In this case, I don't need to. So my final answer, let's just do 3 to the 8th out. So it's big, but it's not like you said, it's not in the millions or the billions. If it starts to get in like the millions, that's a little big. Just leave it as 3 to the 8th. But this I'll write out. 65, 61. Cosine 160 plus I sine 160. So that little shortcut just saved us from having to multiply something times itself 8 times, doing all the foiling, combining like terms. You're probably going to make a mistake if you had to multiply out that much stuff. But that's a lot shorter. Okay, so that's de Moivre's theorem. Okay, so 3 things that polar makes a lot quicker. Multiply, divide, raise to a power. Okay, the homework tonight, just 5 questions. So it's 33, 35, and 37, and 41 and 42. 41 and 42 tell you to do something in the book about changing it. I'm telling you, you can leave it in polar. Just leave your final answer in polar. So we'll go over those before the test, and then tomorrow we have our test on everything for this week.